Hello everyone, I'm Kaushik. I'll be going over DAOS. This will be a very quick introduction and more of a hands-on. So if you like to follow, you can follow with me. So uh, DAOS is distributed asynchronous object store. And this is one of the major file system on Aurora, which has around 230 petabytes of storage. And you can reach up to close to 25 terabytes per second. And one second. And yeah, is it better? Okay. So DAOS has 1024 DAOS storage nodes, and it's designed for massively distributed non-volatile memory as well as an NVMe SSD on each of the DAOS nodes. And storage and retrieval of objects is in a distributed and asynchronous manner, and it's an open source software defined object store. And that's where the distributed asynchronous object store comes from. And Argon still ranks number 1 in the IO 500 ranking. And it's still using only about half of the 1024 nodes. So it's the performance that you see is not the full bandwidth that you see there. And DAOS presents a unified storage model. You have interfaces for POSIX, MPIO, HDFI, and native DAOS file system, and all types of interfaces and tools. And it has advanced data protection, self-healing, redundancy, versioning, and more fine-grained control. So quickly, why do you need to use DAOS? So on Aurora, we have two types of file system. One is the DAOS, and the other one is Lustre. So if you just quickly see the space, like Lustre is just 91 petabytes, and the peak bandwidth that you can get from Lustre is 650 gigabytes per second. Whereas what we currently have in the DAOS user cluster, which is just 128 DAOS servers, you'll be able to get 5 terabytes per second. So the number of servers in the DAOS keeps increasing and reducing. I'll also explain how you can check those things. But I just want to quickly show you the comparison of why you should use DAOS. Also, we have a home space, which is on the Gecko Lustre, which is just 12 petabytes. It's natural to launch jobs from home, but you should not do that. You should either launch, you should launch only from your jobs, only from your project space. So this is a quick comparison on one of our Insight application hack. There is no code changes involved here. They just took their hack application and ran it on Lustre, and they got roughly the 600 gigabytes per second. They just changed the path from the Lustre path to the DAOS path, and they were able to get around 5 terabytes per second. So this is just a motivation of how less of an effort is needed to quickly see your performance gains. And this 5 terabytes per second is because they are running at a lower DAOS cluster, which is currently at 128. So we expect even this to grow further from here, but the Lustre's peak bandwidth is capped. A little bit on the network architecture before we jump into the hands-on of how DAOS and Lustre is placed in the data center, the big picture here. You can see that the Lustre's Eagle Grand or Flare is not directly on the compute fabric. It has to go through the gateway nodes. So there's a bit of a bottleneck there. Whereas DAOS is on the compute fabric, and each compute rack has dedicated lines to the DAOS racks. So what this means is you can avoid storage contention and a lot of interference on the file system side. Um, and a quick picture on how a Aurora compute node looks like and how a DAOS node looks. So you might know by now, Aurora has 6 GPUs, 12 tiles per node, and 8 NICs on the compute node. So each NIC board has 2 NICs here. It is important to use all the NICs. This is not just for DAOS. This might help with all your applications. And the DAOS node has just 2 NICs. So the DAOS storage server node is called an Intel Coyote Pass system. There is 1024 DAOS nodes, 2 CPUs. There'll be 2 engines running on each node. 16 DRAMs, 16 Optane persistent memory, and 16 NVMe SSDs. So each NIC is capable of driving 25 gigabytes per second. So this is the theoretical peak. And if you place your cores correctly and use all the NICs, you should be able to get close to 200 gigabytes per second. So that leads to how do you make sure you use all your NICs efficiently? This is not a hard and fast rule. This is just a recommendation that I always use to balance all the cores and make sure I'm using all the NICs. It is the first core is not available for user. They have some process running on. I just skipped the first row. There's no other reason. You cannot just use 0. You can obviously use 1, but I start from this ordering so that typically people use 12 GPUs on each compute node. So 12 ranks, and we place this 12 ranks in this order to make sure we use all the 8 NICs. Obviously, you can have some binding to add more cores for threads and so on. So this is for future outside the training. If any of the DAOS Insight users want to use DAOS, the first step is you have to send an email to the support to request for your pool allocation. So I'll be going over what is a pool and container and so on. Pool is like a dedicated storage space for your project. You just have to send your project name, the list of users, space, and all the normal stuff. So from this section onwards, it will be mostly hands-on. If anybody would like to follow along, you can follow along. To get started, you will be on your laptop. You access your login node, and then you'll run some compute applications on the compute node. So I hope all these days you'll be using this one, the job submission without DAOS. And the only difference to start using DAOS is you just have to add your DAOS underscore user underscore FS as one of your file system in your QSub. And that's the only difference to get started. And there is one more change that might come along, which is you have to add preload interception library, and you have to add no VNI. But I'll be going over all this now. For now, just the difference in the job submission would be to add DAOS user FS. So if you are on a compute node, the first step would be to load the DAOS module. You have to use use soft modules and module load DAOS. And you can always use this validation steps to make sure if DAOS is actually running on your compute node. You can print the DAOS agent DRPC and check if the process is running. And you can maybe if you are getting 4 nodes or like 8,000 nodes, you can use Clush to make sure if it's running everywhere. So this is just a quick 5 steps to launch your application on DAOS and get a quick performance results. So the second step is a pool. So what is a pool? Pool is something the support would be allocating for your project. This is a dedicated storage. No other projects would be sharing this space, but within this space you can share it with your team members. Uh, so you'll be given a pool name. So for today, it'll be ALSIF training. You can run this DAOS pool query, pool name on a login node or even on a compute node, but just make sure you load the DAOS module before you try this. So this output gives a lot of important results. This will be very useful for future issues and so on. This would be a UUID, which will come back later for each of the DAOS pool. You'll be having a pool UUID, and the targets here tells you what is the total size of the DAOS server cluster you have. So we know that each DAOS server has 16 NVMe SSDs and 16 persistent Intel Optane persistent memory, so 32 targets. So you just divide n targets by 32, and you know what is the total server space you have. And you can also get for this particular pool what is the size of persistent memory, SCM means storage class memory, and what is the space allocated for NVMe SSD. So for today's training, you have up to half a petabyte for your use. So this is the second step after you load the DAOS module. Just query your pool. And the third step is inside a pool, you need to create a container. To make it really, really simple, you can think of it like a directory, a folder. That's it. That's a container. You can have a container for each experiments or sub projects, but do not create one file per container. Like not all your runs needs to be in a separate container. You just need a few of them. So to create a container, you just provide DAOS container create. A type is of POSIX, so you can CD to the location, do ls, check all your files, and the pool name today it'll be like ALCF training, and the container name is anything that you can provide. This is just any label that you can give. So that's all you need to create a container. I will save all this for the later advanced tutorial. So you can append all these options to your DAOS container create later. So by default, the DAOS container create has 3 levels of redundancy. So even if 3 DAOS server goes down, you'll be able to build back your data. You don't have to provide any of those things. This is how a successful output would look like. And you also have other handy convenient tools. You can do DAOS pull list, DAOS container query to query about your container, get some properties about that container, or maybe if I can say it's like a directory, just list what are all the containers you have, do some quick auto test on your pool. And if you want to destroy a container on your allocated pool, you can always do that. And so this is just a quick chart. So you can always fine tune some of these things, which I'll explain in the afternoon session, to optimize your IO and SKUs more performance by changing the chunk size, cell size, and so on. So for now, you don't need any of this. So the third step is basically a DAOS container create. Like I'd say, like after you load the module load DAOS, you just have to do DAOS container create. So the fourth step is mounting your DAOS container. So now that you have created a container, you can mount it anywhere. You can mount it on a login node. You can mount it on a compute node. You can mount it under your directory. but we have this easy handy tool launch diffuse, which would just run a clutch command to mount on all nodes under your queue sub. If it's 8,000, it'll be mounted on this location. You just cd to this /temp alcf training and the container name, and you'll be able to see all your uh, files if there were files before, or you can just make sure if your container is created and mounted and works well. And there is also an optional unmount clean diffuse. You don't have to do that. PBS epilogue takes care of it. But you can also mount it on a login node, but you can provide a temp username, pool name, containers name, so that no two users stamp on each other's container. And you can mount using start diffuse, and it's recommended to unmount it when your work is done. Or it would be taken care of when the node reboots. So this is the fourth step. So after you load the DAOS module, you create a container and you mount your container. That's it. And you can always verify if your mount was successful, and you can CD to that location, and your mount works there. So the last step is about the interception library. That you have to add in your MPI-exec. Just a quick explanation on what's happening here. So the persistent memory and the NVMe SSD is at the lower most part of the stack, and you can access those in different ways. So there is a libDAOS interface and libDFS interface. libDFS interface is the most high performant interface. We can always use that as well. But to make it easier, currently we are focusing on the POSIX interface, which is based on Fuse. And that gives you the nice UA on your terminal where you can see your files and so on. So that's the reason we are focusing on POSIX for now. And using this LD preload of libpal for DFS interception library would bypass some of this user space, kernel space code path, and would improve your performance. This intercepts both the data and metadata, and it would give you close to libDFS performance. So the only addition to your existing code would be to add an LD preload of the libpal for DFS interception library, and a hyphen no VNI tag. And I think even this would go away after a few months. So you can obviously skip this, just don't make any change in your existing job script. But it would be still faster, but you won't be getting the full performance from DAOS. So that's the reason. So that's all you need to get your job allocation, create a container, mount it, and start changing the path to, instead of a Lustre data set path, you can change it to temp, DAOS pool name, container name, and put your data set there or your outputs there. That's all the steps needed to get started with DAOS. So here we show a single node test of why we are using this interception library. So you can see if you are not using the interception library, it is really slow, even as you increase the number of process or cores. But the moment you start adding the libpal for DFS interception library, it is almost very close to the libDFS interface. So this is just a high-level software ecosystem which builds on what we saw before. You can have all your application workflow on the top, and you have several interfaces to access DAOS. There is also an S3 interface, MPIO, and PyTorch. So we'll be going over POSIX, DFS, and PyTorch interface for today. And there is also WAL, which is developed for different I/O libraries, HDFI WAL, NetCDF WAL, and so on. Yeah, so the three interface in the previous MPI exec I mentioned, you can point the directory where you have DAOS to a POSIX path, the temp DAOS pool name and the container name, and you can just use it like Luster. That's where you would have all your data sets, and you also have the DFS interface where you just point slash, and if you have a module load DAOS, and it would recognize the DFS path. And you also have the Python PyTorch interface where you can import PyDAOS and have your data set loader and torch checkpoint and so on. So this is on a single node test where you can see a quick difference between using a POSIX interface and the DFS. There is a little bit of gain there, but at scale, you shouldn't be seeing much difference with the DFS and POSIX. So just one quick snapshot of how a simple job script would look like. So basically, the changes are you will have a file system where you have DAOS underscore user underscore FS, and you load the module load DAOS. You create a container and you launch them on all the compute nodes, and you'll be able to CD to that path. And all these things stays the same. This is an example from an Insight application, Thunder SVM. So the only other difference is you would use an LD preload of the interception library, and instead of a Luster path where they point to the data set, they here you can just point to the DAOS path. So the difference would be like 1, 2, 3, and this one 4 and 5. So these are all the changes that would be on your job script.
Kaushik, I have one question. Does it matter? Let's say you, like right now, I think you have like what, 1024 nodes, or is it, what is that? Is that 1024 is the number of nodes, or was it something else?
Number of compute nodes or number of DAOS servers that you're asking?
Okay, so that's the question. So if I want to submit a job, let's say on one rack, does it matter that the DAOS pool that I created are
Okay.
on that many nodes or not really?
Okay, got it. So this job script shows you'll be running this job on 512 compute Aurora compute nodes, and what you're asking about is about the DAOS nodes. How many DAOS nodes that you're using? So this is not under user's control. So currently we have 128 DAOS servers, and you can verify this using the DAOS pool query command that I mentioned, and you will know how many DAOS servers are in use, and your space, your dedicated pool space could be everywhere on the 128 DAOS nodes. So that's where the distributed object store comes from. It's all sharded across all the DAOS nodes. So in your job script, you don't have to worry about how many DAOS servers that you're using. So all this would be taken care of in the background. So yeah, and for the hands-on, today you can grab an example from this location where you have a simple DAOS peak test. You can give at least, you can try it on a single node or a couple of nodes, but to actually see the 5 terabytes per second versus the 0.5 terabytes per second on Luster, you should at least use 192 compute nodes or more. Keep your wall time under 5 minutes. If you are doing any scale test, it shouldn't take more than 5 minutes to do an IOR. So you can do 2 tests here. Basically, on an IOR app where it does a 5 iteration of writes and reads with block size of 1 GB and a transfer size of 2 MB. You don't have to build IOR, it's in this path, you can grab it from here. So the first test that I would do is just point this -O to a luster path and see how much max read bandwidth and write bandwidth that you're getting. And then change it to a DAOS path, and you can see the difference. And you can also change it to, from there, you can change it to a DFS API instead of a POSIX API, and you can compare these 3 differences, and you can note what is the performance that you are getting from DAOS versus Luster. And so this is one of our old results, which was on a very small DAOS cluster. Currently, we have one bigger than that. So you can see that as you scale the number of compute nodes and you increase the number of tasks per node, PP and process per node, you start to see increased write and read bandwidth. So that's the reason I said 192 compute nodes would be a good number to see the peak test. And so let's say if you have a petabyte of data on your Luster and you want to move it to DAOS, we have a lot of tools that it can do to copy data, move data around. So you can just CP your Luster path to the DAOS path. This should be good for all small tests. There is also a tool called DAOS file system copy, where you can just mention the source and the destination. For these things, you can do it on a login node. You don't need a compute node. For this one, you don't even have to mount your DAOS pool and container. You can just point there. And the third one is really interesting. You might, if you are not aware, this is from MPI file utils. It's not just for DAOS, for anything. You can move a lot of data, especially when it is metadata intensive, like billions of tiny small files that takes a long time to move around. Even if you tar it, untarring would be expensive. So you can grab this DCP tool from this location and allocate a lot of cores, CPU cores, or even more nodes to move data around from source luster path to another luster path or to a DAOS path. So, and it would give you some interesting results to move data, DAOS data around. And that's pretty much it for getting started with DAOS. So so there'll be some obvious question on how DAOS is different from Luster. We would have, other than the 230 petabyte space and the peak performance of 10x or 50x, there are a lot of advantages which DAOS provides. Unlike Luster, you don't have to worry about Luster file settings, tribe count, and when you are when you do a read modified write, there is no locking concepts in DAOS. If I can make it really simple, if you have int I equal to 2 and you just want to change to 3, you will just append another version I equal to 3. Now you have 2 versions of I. You just pick the latest one, so there is no locking and modifying it. So this applies to like huge data sets as well. And you have bright distributed key value store. There's no kernel code. There is no one centralized global object table. And it also has storage efficient erasure coding, self-healing, fine-grained access, and so on. And another advantage is maybe we might have seen with different IO libraries that people often create many different subfiles to improve performance. You don't have to do any of those things. These are all taken care of by DAOS underneath. So you just can have one checkpoint file or one huge DAOS dataset tar file or a HDFI file or even a text file. Like it doesn't matter how many input files you have or how many output files you have. We get the same peak. So this is also another advantage. And so DAOS is now a part of the Linux Foundation. There are a lot of collaborators with us. And you also have a rich documentation on the LCF docs and some best practices that you can follow. So I would stop here for the intro section. Maybe we can do the hands-on, and then we can move on to the advanced section after this.
Thanks, Kaushik. I have one question. What is the self-healing data protection that you mentioned?
So I'll cover this in the afternoon tutorial, but basically there are a lot of storage efficient schemes and algorithms where you don't have to have multiple exact copies on two different targets. So these are all happening in the background. You don't have to see all of those things. So if one node goes down, it can build back the data, and there's fault domain erasure coding and replication that we'll see in the afternoon session. But most of these things a user don't have to see in their job script. These are all taken care of in the background. So that is usually for questions like what DAOS offers compared to Lustre and why I should move to Lustre and so on.